And if we have systems of inequalities here to solve word problems, sometimes you hear this called maybe by different names. Linear programming is a term that's sometimes used. It sounds a lot fancier than what it really is. But here's the steps that we're going to use to do this. First, we're going to identify the goal of the problem. Typically, these problems are meant to maximize or minimize a particular value. We're going to write an equation for that goal. Okay, we're going to identify the constraints. A constraint would be anything that's preventing us from just making an infinite number of whatever the terms are and so forth. We're going to write an inequality for each of those constraints. We're going to graph those inequalities, identify the vertices of that shaded region, and test those to determine the final answer. Okay, so here's a great word problem from the toy factory. Auto Toy builds toy cars and toy trucks. Each car needs 4 wheels, 2 seats, and 1 gas tank. Each truck needs 6 wheels, 1 seat, and 3 gas tanks. His storeroom only has 36 wheels, 14 seats, and 15 gas tanks. He needs to decide how many cars and trucks to build so he can maximize the amount of money he makes when he sells them. He makes $1 on each car and $1 on each truck he sells. This is a very, very small business, obviously. Good, Small Business Saturday's coming up. All right, so first of all, we want to identify the goal. So the goal here is found about midway through the problem. Okay, it says here that he wants to maximize the amount of money he makes. Okay, he makes $1 on each car and $1 on each truck. So we need to identify those. Okay, so we're maximizing profit. All right, so we're going to write an equation for profit, and that's going to equal $1, okay, for every car that he sells, plus $1 for every truck that he sells. Now, C and T, we're going to have to graph these eventually, so C and T might not be the best. It might be better just to say, you know what, we're going to let X be cars, and we're going to let Y be trucks. That way when graphing time comes, things work out a little bit nicer. We don't have to worry about, getting goofed up on which is which. So let's make that X and make that a Y. So that's the first 2 steps there, identifying what we're trying to find and then writing an equation for it. Now we move on to the constraints, because in a perfect world, Otto would have unlimited resources and he could make as many cars and trucks and sell as many cars and trucks as he wants, but that's not the reality that he lives in, because his storeroom here is small. It has 36 wheels, 14 seats, and 15 gas tanks. So these are our constraints: wheels, seats, gas tanks. Okay, so the constraints here are wheels, seats, and gas tanks. We need to write an inequality for each of those constraints. In other words, how many wheels does it take to make a car? How many wheels does it take to make a truck? And that number has to be less than or equal to the total number of wheels that he has. So if I read the problem up here, I see that he needs 4 wheels for a car and 6 wheels for a truck. So I would say that that's 4x and 6y. Because remember, x is cars, y is trucks. That total has to be less than or equal to 36. Okay, and then I move on to seats. Here he has 2 seats for a car and only 1 seat for a truck. So the seats would say 2x plus 1y, and that's going to be less than or equal to the total number of seats, which is 14. And last, I have gas tanks. So a car gets 1 gas tank, a truck gets 3 gas tanks, and there's 15 total gas tanks to go around. So 1x plus 3y has to be less or equal to 15. All right, these are the constraints that I'm going to graph. Okay, once I graph them, they're all less than, so I'm going to be shading underneath all of them. I'm going to find the vertices of the final shaded region and use those in the profit equation to determine which one yields the most profit. So what I'm doing now is finding the extremes. So let's see here. If I can, maybe I can just copy paste this. Let's see. Group. What are the odds? Maybe not. Nope, not going to let me do it. Okay, so memory, here we go, 4x, 6y less than or equal to 36. So first I have 4x plus 6y is less than or equal to 36. Okay, and you can use any strategy you want to do these. I'm going to use my intercept. So if I cover up, there we go. If I cover up my x's, right, I get my y. So I have 6y equals 36. So y equals 6. And if I cover up my y's, I get my x's. So I have 4x equals 36, which means x equals 9. So I plot those two values. So I'll plot x9 and I'll plot y6. I shade, or excuse me, I graph that line, okay? And the shading is going to be underneath because it's less than, okay? I'm not going to shade that yet. All right, so then I do my next one, okay, which was 2, 1, and 14. So let's see here. So now I have 2x plus 1y less than or equal to 14. I'm going to use the same strategy, right? This. Okay, so y equals 14. Oops. Okay, 2x equals 14, so x is 7. And I'm going to connect those dots. Okay. It's very imperative that you draw straight lines because we're going to be looking for intersection points. Okay, and the last one there was 1x plus 3y less than or equal to 15. So in this particular case, x is 15. Y is 15. So y is 5. So if I go 5 for y, and 15 for x, and connect those dots, I'll have all three inequalities shaded. Now if you're using colored pencils, you can shade all three of these different colors. I can't shade lightly on this. I either shade or I don't shade. But I'm looking for less than all of them. Okay. So I want to make sure I stay under every line as I do my shading. But like I said, if you're using colored pencils, it works out much nicer for you because you can just shade lightly with each colored pencil, and then you'll see the overlapping region when you're all finished. All right, and then I'm going to identify my vertices as the next step. So that will be all the points, the corner points of this shape. Okay. And putting dots there is only one step. I actually want to write the coordinates of each of them. Okay, so if I write the coordinates of each of my vertices, I have 0, 0. Chances are that's not going to be the one that gives me the most profit. I have 0, 5. Right here, 0, 5. Okay, this one here is what? 1, 2, 3, 4, 5, 6, 7, 0. Okay. And then here I have 6, 2. Then this one here I have 3, 4. I'm going to plug each of these x and y values into my profit equation, which says 1x plus 1y. So obviously this one here, 0, 1 times 0 plus 1 times 0 gives me a profit of 0. Here I have 1 times 0 plus 1 times 5 gives me a profit of $5. This one I have 1 times 7 plus 1 times 0 gives me a profit of $7. 1 times 6 plus 1 times 2 gives me a profit of $8. And finally 1 times 3 plus 1 times 4 gives me a profit of $7. So I find out to maximize my profit, I should construct 6 cars and 2 trucks. It's a long process. It's a bit of a tedious process, but it works, and it's not beyond us. We all know how to graph inequalities. We all know how to shade, and we all know how to plug numbers into an equation and solve. So we're going to get lots of practice in class.